Well, hi everybody. Hi. Hope everybody's well, and welcome to another video from Raspberry Pi and the older generation, Adventures in Tech. Okay, today we're going to carry on. We're going to carry on with our C++ and our Arduino. But in this video, I want to introduce you to PWM, pulse width modulation. All right. Now, pulse width modulation, we know that the output from the Arduino is 5 volts. And on a digital pin, we cannot control the brightness or the darkness of an LED. All right. Or for that matter, the speed of something, go faster and slower. So we have to use a thing called pulse width modulation, and the way it works is pulse width modulation reduces or increases the voltage or the time of the voltage going out of that pin. So it doesn't lower the voltage, it lowers the time or increases the time of the voltage going to the pin. Right, now I don't know if you remember, let's go over and have a look. When I showed you the pin outs, I showed you that some pins have pulse width modulation, or can be used for pulse width modulation, and they are the ones with the numbers with the little squiggly line. Remember that from our earlier video? All right, so we've got 3, 5, 6, 9, 10, 11. On this occasion, we are going to use pin 9. Let me quickly show you the circuit so you can see. It's a simple little circuit. But in this video, we are concentrating on the code. All right, the code for the pulse width modulation in C++. Now, let's go over to our coding view. So you've seen that, you've seen the simple little circuit. We built that circuit before, but on this occasion, we're going to pin 9. Okay, we're going to pin 9. Now, remember I told you before that about variables. Don't know if you know about variables. What a variable is, we can name something, right? And instead of, if we have to change anything in our code, instead of changing everything right the way through the code, we just change the variable. Right? We just change the variable. So what I'm going to show you is the first variable we want. Right, it's an integer, so it's int, right, and it goes above the void setup. LED equals, we're on pin 9. Okay, so that's made our variable. All right, the word LED stands for number 9. So now if we want to change the pin number anywhere, instead of changing the number throughout the code, we just have to change the variable at the top. So if we want to move to pin, for instance, 3, instead of going through all the code and changing it to pin 3, we just change the variable from 9 to 3. Okay, so let's go back to 9 and enter. Now, we don't want another integer, and this is going to be called brightness. All right, brightness, that equals 0. Okay, sorry, guess what I forgot? The semicolons on both. Okay, so the word brightness stands for the value that is emitted. Okay, So at the PWM, the number 0 is only used as an initial value. So we're using that as an initial value. All right. Now the next variable, int. And this variable is going to be called fading. Okay. And that equals, and the fading sets the speed. This is going to set the speed of the fading. All right, so we can have it at what we want. At the moment, we're going to put it on 5. Semicolon. All right. So that is our 3 variables. Notice how it comes up. Variable brightness. All right. So that makes our life a lot easier if we want to change our code. Right. So let's come down here a bit. We're now going to go into our void setup. Remember, this is the start of the void setup. This is the end of the void setup. So it has to go inside the curly brackets. First thing we need to do, of course, set our pin mode. Remember the capitalization. All right. Yeah. And it's brackets on. It's LED. So we're referencing that variable, comma, space, and we want it as an output. All right. Remember, it's already put our brackets. Come outside the brackets, semicolon. All right. No problem at all. Oh. Now we're going to go to our void loop. Let me just come down here on my notes. Because what I want to try and do is try and tell you as much about the new functions, especially new functions. So we've got a void loop. We've now got a new function. Analog. I think that's how you spell analog. A-N-A-L-O-G. Yeah. Right. Brackets on. Okay. Automatically gives us our brackets off. Analog right. It's a new function. Right. And we're going to go LED, comma. And we want to reference LED and its brightness. Right. So we're referencing this brightness, this variable. All right. So brightness, come outside the brackets and semicolons. Now we notify the value of the PWM output. We had the value of the the function analog right is used to activate the PWM output on the pin LED, which is number 9. All right. So in this, yeah, okay. Enter. So our next command. Hope you can all see that. Trying to make it as easy to see as I can. Our next command is brightness. Okay, equals brightness plus fading. Okay, plus fading. Semicolons. All right, so now we're going to modify the PWM output each time. Right. Next, we want a delay. Another function. And 25 seconds. Okay, come outside, semicolon, enter. So we put our delay. Right. Right. I just don't want to get this. So the LED should only stay bright for a really short time, like 25 milliseconds. If you reduce that time, the fading will also get faster. All right. So now we've got an if command. Okay. Okay, it's another. What is it? Another function. Yes, it is. Brightness. Okay. Brightness equals 0. And it's 2 straight lines. That took me a little while to find this. I think it's these. 1, 2. Okay. 2 straight lines. Space. Brightness equals space 255. All right. Come outside the brackets, and it's curly brackets on. Gives us auto curly brackets off, and fading equals space minus fading. All right. Semicolons and curly brackets off. All right. Meaning that this command in the value of brightness will go from 0 to 255. Okay. And let me just check. Okay. That should be it. That should be it. And we come down to our final curly bracket, which closes that bracket, closes that bracket. All right. So hopefully this will work. Let's verify it. Make sure we've got no issues with our sketch. Wait for the little green line to be happy. Down here at the bottom. Done compiling. Okay. Let's rock and roll. Let's go for it. Wait for it to download. Compiling sketch. Compiling done. Great stuff. Great stuff. Let's go to overhead. And there we are. We have configured pulse width modulation, PWM. So what this is doing, it's not changing the voltage, it's changing the time of the voltage. Okay, the amount of voltage is not changing, it's the timing. So more time, less time. More time on the voltage, less time on the voltage. And as you can see, we are getting a fading LED. Okay. I think we needed to do that quick lesson just to introduce us to pulse width modulation. Quick and easy. All right. But as you can see, there are differences. There are differences in different codes and the way we code things. Okay, well, thanks for watching this video. Hope you enjoyed it, and I'll see you in the next one with some more Arduino as we push on. Thanks very much. Bye-bye.